Hello. In this lesson, we'll see how to properly rotate a figure given a certain degree of rotation uh, in a given point of rotation. So let's see how do we go with our construction. So our objective is to get this figure, triangle B, and rotate it on a clockwise direction. We want to get this figure, and then we just want to rotate it under this direction, but we cannot just say, well, just going to rotate it, it's going to land here. We want to be as precise as possible. Well, we know that when we try to rotate a figure, the image, the points or the image or the vertices of the image and the pre-image should be equidistant. So knowing that, what we're going to do here is we're going to create some arcs coming from the pre-image points. So what I'm going to do here, I'm going to get my compass. I'm going to put one leg on the center of rotation, and I'm going to do the other leg on one of my vertices, and I'm going to create an arc coming from that point. Coming from this point, because I know that this image, if I'm going to rotate it on a clockwise position, the image of point C should be somewhere in this arc. Because we know that the image, at least the vertices from the image and the pre-image, are always going to be equidistant to the origin, to the point of rotation. So I'm going to take advantage of that property. So I'm going to do an arc and I'm going to label this arc C, because I know that whatever my rotation is, the image of point C should be somewhere in this arc. And I'm going to do the same for the others. I'm going to do the same for, oops, sorry about that. I'm going to do the same for point B. Okay. So let's go back here. Okay, so now that I'm exactly in point B, let me just change the color just to make it a little bit more nicer, I guess. Same idea. I'm going to draw an arc. I'm going to draw an arc coming from point C, B, and I'm going to label this arc B because the image is going to be somewhere in this arc. And I'm going to do the same for point D. What color am I not using? Let me just choose purple. Cool. So let me go here, same idea, make sure that one of the legs is on the point of rotation, the other leg it's on the vertices that we want to reflect. So, all right, so now we got 3 arcs. I know that the image of point C is going to be somewhere in this arc. I know that the image of point D should be somewhere in the purple arc. And I know that the image of point B should be somewhere in the orange arc. So at least I have taken care of the distance to the point of rotation. Now, what I really want to concentrate now is the actual angle of rotation. We got this image, and we want to rotate it this angle, this angle to in a clockwise position. So what we're going to do now is we're going to come back to our angle here. We're going to come back to our angle. We're going to put one. Let me just move this angle a little bit lower so my compass can actually fit here. Okay, so what we're going to do here, we want to construct a congruent angle. But in order to construct congruent angles, first, I need to make some kind of a measurement of my angle. Let me actually change this colors to black. Okay. So I want to build a congruent angle somewhere in here so that my figure can actually follow that direction. The way that I'm going to go about constructing that congruent angle, because if I want to move the original figure theta degrees clockwise, then this angle of rotation should be equivalent. So what I'm going to do here, now that I have taken care of this mark, using this same distance, I'm going to come back to the actual problem that we have here, and I'm going to create a circle using the distance that I use here to measure my angle. Okay, let me make sure that this is the same. So notice that what I did here, I got this mark coming from the angle that we want to rotate it, and using this distance, I created a circle. Why do we create this circle? Because now, in order to see how many degrees, let's start with point C. To see how many degrees point C should be rotated to the right hand side, what we're going to do now, we're going to get just a line. We're going to create a line that goes, let me make this a little bit smaller. We're going to create a line that comes from the origin to point C. And you can think about this line as if it was the base of the angle right here. you can think about this line because this is where my angle starts. This is kind of like where my angle starts. So now to see where I can place the second ray to create my angle, what I'm going to do here, I'm going to use my compass and I'm going to measure the distance. I'm going to measure the distance between the initial ray and the terminal ray here. So I know that this distance is the distance that needs to be traveled in order to create this angle. So now using this, I'm going to come back here to my problem. I'm going to place one of the legs here where the circle that we created using this arc. And I'm going to see where does my, and I want to see where, oh, let me actually change colors here. So, because we're using red, so let me move this to red. Now, whenever I see this mark, I know that if I create a line that goes still from the origin to here, this angle right here, it's equivalent to this angle right here, because this is the original line, which is the one that we started right here, and I measure this, and I measure this distance, oops, and I measure this distance right here, and this is the same distance that I use to create the distance among angles here. So now using this distance, I know that if I create a different line here, this is exactly the rotation, the angle of rotation that needs to be created. So that means that the image of point C, should be exactly right here. Because we know that this arc was going to give me the image of point C. And now using this measurement, I know that point C travels theta units to the right-hand side when it goes from here to here. So this is how my rotation, or this is how my point of rotation will go on a clockwise position. Now that I have done this for point C, I'm going to repeat the process to rotate every other point in the vertex. So I'm going to do the same. What I'm going to do is I'm going to start by making a line. Let's try to move vertex B. I'm going to start by looking at the origin. I'm going to draw a line to the vertex B. Now, again, I'm still going to use the same measurement right here. I'm going to measure the distance between these two lines, these two rays. I'm going to measure this distance. So here it is. Now, using this distance, I'm going to come back to my problem. I'm going to place one of my legs here, because remember, this black circle right here is the circle that I'm using to create my angles. So one of the legs is going to be right here, where my first line intersects the circle, and I want to see where it intersects later. Oops. And I want to see where it actually intersect now. So let me just change this to orange. And I know that, oops, let me make this a little bit not that thick. Okay, so I know that if I create a line coming from the center to where this arc intersect the circle that I used to create my angle, which is going to be exactly right there. I know that if I measure this angles right here from this line to this line, it will be the same measure as the angle of rotation that we wanted to. So all I gotta do is where does this second line touch my arc, which is going to be exactly right here. So this is where B prime is going to be located. I guess I forgot to say that this is where C prime is located. So now I know where B prime is. I know where C prime is. What I got to do is, well, using the same idea, I got to see, well, where does D prime is located. So using the same process, I'm going to come back here. I'm going to start by making a line that intersects D. And again, notice that I'm still using the same measure for all the arcs that I'm creating here. Using this measure, I'm going to go back here using my circle that will indicate my angle. One of the legs is going to be on the first line, and the second leg is going to be where my mark intersects the circle. So here it is. If I create a line that goes from the center to where my second mark intersects the circle right here, I know that this distance is theta units. which is exactly the angle of rotation I want to see. And where does this intersect my arc is going to be right here. So now this indicates that this is D prime. So now, if I connect everything that I have done so far, I can see that. Let me just create the image. If I connect the images, the points of the image, then I should get the same figure. Oops, let me actually make this a little bit thicker just to differentiate with all the mess that we have here. So if we connect all this, I know that this triangle that I have just created, it's going to be the same angle. Well, I'm sorry, the same triangle, the blue triangle BDC, but it is rotated theta units to the right. So you get this triangle. If you rotate it theta units to the right, you will have the following figure. So remember, here is where point B stands. This is where C prime is. And lastly, this is where D prime is. All right. Well, I hope this is helpful, and I'll be seeing you later.